In this lesson, we will continue to practice working with sine, cosine, and tangent. So as I go through, I'm going to be assuming that you have memorized the three key formulas. Sine is opposite leg over the hypotenuse, cosine is adjacent leg over the hypotenuse, and tangent is opposite leg over the adjacent leg. If you have trouble memorizing that, you might want to use the magic word SOHCAHTOA, which reminds us that sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. Let's go. So for problem number 1, we have sort of two problems in one. Students often get this confused. First, we're being asked to find the cosine of angle P. Notice that we're not being asked to find angle P itself, just what's the cosine. Let's circle the angle and label the sides. So we're talking about angle P, so I'm definitely going to circle angle P. When we label the sides, we always want to start with the hypotenuse, and the hypotenuse is always across from the 90-degree angle. Now, across from the angle, you will find the opposite leg, so that makes 8 the opposite leg. Right next to the angle is the adjacent leg. So now we've labeled the sides. Now, thanks to SOHCAHTOA, we know that cosine is the k part of SOHCAHTOA. Cosine is adjacent leg over hypotenuse. So when we set up to find the cosine of P, we're going to say the cosine of angle P, and then we will write the adjacent leg, which is 6, over the hypotenuse, which is 10. Now we should reduce this. Okay, cosine of angle P is 3 over 5. And that's it. That is the answer if all I'm asking you to find is the cosine of angle P. Now, what if I asked you to go further and find the actual measure of angle P? Well, we can start with what we just found. Okay, we would start with the fact that the cosine of angle P is 3/5, but this is how they ask us to find the actual value of the angle. They'll say find the measure of angle P. So if you want the variable, the angle from the inside, that's when you do the inverse trig function. So angle P will equal the inverse cosine of 3/5. And that is something you can put in your calculator. Okay, inverse cosine of 3/5. 53.130 degrees. Alright, notice that these are two separate questions. If I ask you for the cosine of the angle, you stop here. If I ask you for the actual value, the measure of the angle, then you use your inverse trig function and find me those degrees. Problem number 2, for triangle LMN, we know that the sine of angle L is 4/5, the sine of angle M is 3/5, and the tangent of angle L is 4/3. Using this information, we need to find the cosine of L, the cosine of M, and the tangent of M. Alright, well there's a special property that we've learned. So they're using L and M, so those must be acute angles of a right triangle. So we have learned that the sine of one angle, one of the acute angles, I'm not talking about angle N, L and M, the sine of one of those angles should always equal the cosine of the other angle. Okay, so the sine of L should equal the cosine of M, for example. And also I could say the sine of M, whoops, the sine of m should equal the cosine of n. No. I'm sorry. We're talking about L and M, not N. So the sine of M should equal the cosine of L. So the sine of one angle should equal the cosine of another angle. So since they told us that the sine of L is 4/5, okay, they told us that the sine of L is 4/5, that means that the cosine of M has to also equal 4/5, because these are equal. So that is one of the things that we were supposed to find. Okay? So we just found the cosine of M. They also gave us that the sine of M is 3/5. So they gave us that this is 3/5. Now that should equal the cosine of L. So the cosine of L should also equal 3/5. Okay, that's another thing we were supposed to find. Alright, so that's it for that principle. Now, here's another principle that we've learned. Sort of a special pattern. This one deals with tangent. It turns out that the tangent of one of the acute angles in a right triangle and the tangent of the other acute angle will always be reciprocals of each other. When I say this word reciprocal, I'm talking about 2/3 and 3/2, for example. These are reciprocals. So when they give us that the tangent of L is 4/3, then the tangent of the other angle M must be 3/4. They have to be reciprocals of each other. And the tangent of M is the third thing that we were supposed to find. Alright, so there we found all three. For number 3, we first must fill in this blank with sine, cosine, or tangent. So is it the sine of angle R that's 5/8, the cosine of R, or the tangent of R? So we're dealing with R, so let's definitely go ahead and circle angle R, like we do. And then we like to label the sides, starting with the hypotenuse. So you know that the hypotenuse will always be across from the 90-degree angle. That makes this the hypotenuse. And then the side that is across from the angle is going to be the opposite side. So this is the opposite side. Now the side that's right next to the angle is the adjacent side. So now we've labeled everything. Now, one of these three sides is not helping us write a trig function because there are no values there. So we have the 8 is the hypotenuse, the 5 is the opposite leg, and then we have the adjacent leg that's got nothing going on. So let's throw that out for a moment. So we're really choosing between SOHCAHTOA. Alright, remember that magic word I showed you at the beginning? SOHCAHTOA. Alright, representing sine, the sine formula, the cosine formula, and the tangent formula. The adjacent leg is the one leg that we do not have. So notice the two functions that involve the adjacent leg, cosine and tangent. So I'm going to have to throw those out because they both involve something that we don't have, and we're trying to set up this trig function. So it must be the sine function. So notice that the sine of angle R would be opposite over hypotenuse. That would be 5/8. And that's exactly what we have here. So it must be the sine of R that is 5/8. Okay, now erase, erase, erase. Part 2 of this problem they're telling us to use the Pythagorean theorem to find the third side. So let's call the third side x, and let's go for it. Remember, when you do the Pythagorean theorem, you might have learned a squared plus b squared equals c squared. Please understand that the c has to be the hypotenuse. So the 8 has to go over here by itself. So we will write x squared plus 5 squared is equal to 8 squared. Alright, the hypotenuse has to be the c. So that's going to be x squared plus 25 is equal to 64. And then we will subtract 25 from both sides. That gives us x squared is equal to 39. Then if we take the square root of both sides, we get x is equal to the square root of 39. Now they told us to round our answer to 3 decimal places, so that means we need to use a calculator. So that's 6.245. The next number is a 9, so got to round up. 6.245. Okay, number 4. Alright, so we want to solve this for x. We're going to use the same procedure over and over again. Step 1, circle an angle. Step 2, label the sides, starting with the hypotenuse, which is always across from the 90-degree angle. Then label your opposite and your adjacent. The opposite side is across from the angle, so that makes this the opposite side. The adjacent side is right next to the angle. Now we've labeled everything. Now we're going to choose between SOHCAHTOA. SOHCAHTOA. Alright, that's the sine formula, the cosine formula, and the tangent formula. To help us choose, we will decide which one of these 3 sides we're not using. So we're using the adjacent side because it's got the 12. We're using the opposite side because that's what we're looking for, the x. The hypotenuse in this particular problem is not being used at all. It's useless. So notice that these 2 functions involve the hypotenuse. So we won't be able to use them. So throw them out. That just leaves the tangent function. And this conveniently reminds us that tangent is equal to opposite leg over the adjacent leg. So we will set that up. So tangent of the angle you circled is equal to the opposite leg, which in this case is x, divided by the adjacent leg, which is 12. When the variable is in the numerator, that's when you multiply. Okay, so these will cancel each other out, and that will give you the final answer. So just put this in your calculator. 12 tangent 59. 19.971. Okay, number 5. We want to find the side marked x. We will go through the same steps again. Start by circling the angle that you have, and then label the sides, always starting with the hypotenuse, which is across from the 90-degree angle. And then label your opposite and adjacent. The opposite leg is across from the angle you circled, so this is the opposite. The adjacent leg is right next to the angle that you circled. Now choose between SOHCAHTOA. In other words, choose between the sine function, the cosine function, and the tangent function. To help you choose, look and see which one of these sides we're not using. Well, we're going to use the opposite side because it's got the 97. We're going to use the hypotenuse because that's the x that we're looking for. It's only the adjacent side that's got nothing going on. Alright, we're not looking for it and there's no value given. So the adjacent side is useless. Okay, notice that both of these functions involve the adjacent side. So these functions are going to be useless in this particular problem. That just leaves the sine function. Sine is opposite over hypotenuse. Set it up. So we will say the sine of the angle circled is equal to opposite over the hypotenuse. So when the variable is in the denominator, that's when you want to swap these. So we're going to wind up with x is equal to 97 over sine 55. Okay, we're just swapping these. And then this is what you get. But this is something that can easily be put in the calculator. So we will just go 97 over sine 55. $118.415. Okay, last one, we're going to do the same thing again. Start by circling the angle. Now, we're not given any angles, but I'm still going to circle this one because that's what we are supposed to find. Now we're going to label the sides, starting with the hypotenuse, which is right here, because the hypotenuse is always across from the 90-degree angle. Then we will label opposite and adjacent. Across from the angle that you circled is the opposite side, the opposite leg. Right next to the angle that you circled is the adjacent leg. Now you must choose between SOHCAHTOA. Alright, are we going to use the sine function, the cosine function, or the tangent function? To help us decide, let's see which one of these three sides we are not using. Well, we're using the adjacent side because that's 25. That's a number we can use. The opposite side is 84. That's a number we can use. The hypotenuse, boo. Nothing going on here. We don't know what it is, and we are not being asked to find it. The hypotenuse is useless. Notice that the sine function and the cosine function both involve that worthless hypotenuse. So, for this particular problem, we're not going to be able to use sine or cosine. So that leaves tangent. And this reminds us that tangent is equal to the opposite leg over the adjacent leg. So let's set that up. We will say the tangent of the angle that you circled, which is an x, is equal to the opposite leg over the adjacent leg. That's 84 over the 25. Now, when you want to find the angle that's inside the trig function, that's when you do the inverse trig function. So we will say x is equal to the inverse tangent of 84 over 25. And then this is something you can put in your calculator. Okay, for inverse tangent, that's just second tangent, and then you go 84 over 25. So that is 73.426, got to round up, degrees. 73.426. So notice that's a nice little review of the three types of problems that you're going to run into. Sometimes the variable is in the numerator, sometimes the variable is in the denominator, and sometimes the variable is inside the trig function. So remember, when the variable is in the numerator, that's when you multiply. When the variable is in the denominator, that's when you swap these. And when the variable is inside the trig function, that's when you do the inverse trig function of the answer. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.